Hello and welcome to this Micrographics and Autodesk webinar. This webinar is going to cover the product design extension with Fusion 360. My name is Carl van Rooyen and I'm an application engineer with Micrographics. Among other duties, I facilitate Fusion 360 training, mainly based around its CAD and CAM aspects. If you'd like to make contact for any reason, my contact details are at the bottom of the slide, and we'll have the contact details for Micrographics at the end of the webinar as well. We previously had some technical difficulties with the live stream of this webinar, and so we've uploaded this recording in its place. With that being said, let's have a look at our agenda for the day. I will start off with our introduction. Here we'll briefly discuss what Fusion 360 extensions are and which ones are available. In the introduction, we will also take a look at why you may want to use the product design extension and introduce you to the included commands that we'll be looking at more in depth today. The first of these commands will be the ability to create plastic rules and assigning them to components. We'll also look at creating preset commands. Then I'll be looking at the specific plastic design tools that are unlocked with the extension. These are Boss and SnapFit. Then we'll move on to geometric command, the geometric pattern command, design advice, organic mesh, conversion, which allows you to take scan data and convert it to T-spline data before we move on to volumetric lattice command. And then we'll close off with the summary. In the introduction, I'll explain a little bit about the extensions, as mentioned. So Fusion 360, as an off-the-shelf product, has a certain set of features. For most people, those features are more than what is required for them to get their job done. But you'll find that certain users need extra functionality. They need to be able to do extra things. The extensions allows them to gain extra functionality, or in some cases gain unlimited access to certain features within Fusion 360. We typically find that those users are specialists within a specific field. Here I've got a couple of fields noted: generative design, simulation, additive manufacturing, machining, and nesting, just to name a few of the fields where there are extensions that can assist. Now, some of these will add, as I said, extra functionality, such as the nesting extension that will allow you to create more advanced nests of materials and create nesting reports. The machining extension gives you an extra toolpath for surface finishing and toolpath editing functionality, amongst other things. And then there are some extensions that allow you to gain unlimited access, like generative design and simulation. These are typically the cloud services that require tokens to use. So with generative design, where you want to create a study, you are required to spend tokens for that study to solve. Where if you have the extension, you would be able to solve as many as you want without having to worry about the tokens required. The same goes for simulation as well. Each cloud-based simulation would require a certain amount of tokens, and if you have the extension, you'd be able to simulate without the use of those tokens. As mentioned, today's webinar is about the product design extension. This extension will unlock extra design features within Fusion 360 that allow the designer to create more complex components quicker. I've taken the product design extension and broken it down into two different focus areas. One area has quite a lot of focus on plastic part design, and the other area unlocks a couple of tools which will help you with other workflows within the design environment. Looking at the first area of plastic part design, we see that they are typically quite complex in nature and functionality. Whether it's a cover on a piece of electronics that is molded, that has molded in clips to clip together, or a housing for a power tool that has to screw together and be serviceable. What we see with the extension here is that we are able to automate the creation of specific features and create design rules that will help with this. At the end of the design process, we would be able to run checks for specific issues related to the part itself and the manufacturability of it. Let's say we're looking at injection molding. We can look at the part and answer questions such as, are there areas that are too thick? Are there areas that have knife edges? Are there areas that don't adhere to those design rules that were specified? There are tools in the product design extension that will help with plastic part design. Having a look at the other area of the extension, we see that we can speed up the design process using rules and presets. Certain commands will pull information, such as parameters, from those rules, helping speed up the design process and reduce the amount of input required from the designer. We can also use the convert option to convert mesh data into T-spline data. So if you're doing reverse engineering, you would be able to convert a mesh obtained from a scan using the organic conversion option in the extension. Then lastly, you may want to be able to create complex geometry quickly, and there are tools in the extension that can assist you with this. Moving on to the first section, we will have a look at plastic rules. For those that have worked with sheet metal, this is very similar to that, where you would create a set of rules similar to your sheet metal rules. If I had to draw comparisons from a sheet metal side, where you set your sheet metal thickness and bend radius, where here with your plastic rules, you would set up your plastic material to be used. Then for the material itself, you would set up the thickness that you want to adhere to throughout your design process. You can see a couple of options on the right hand side there with regards to the range of thickness that is allowable. At a later stage in the design, you'll be able to check against this and have warnings if it's outside of that range. There is also a draft angle option, and depending on the plastic you're working with, you can adjust the draft angle accordingly. You can also see on the left that there are other options that I've not mentioned. But you might be asking, why do we have these rules and presets? Which we'll talk about on the next slide. These rules allow you to ensure design consistency when creating the plastic rules. You're saying with this specific plastic, we want to have a specific draft angle and or a specific minimum draft angle as well. And so your designers can assign the rule and then know that those values are being carried across throughout the design. Having these rules allows for design consistency. It also allows you to automate designs to some extent. We'll see in the demo that when we create and shell a component, the shell thickness for the wall automatically pulls the thickness value from the rule. So we're shelling to that predefined thickness. Also, when adding a draft, the draft angle is pulled from the rule so that we don't have to go and find that draft angle and input that draft angle into the draft dialog box. Rules will also allow you to check for manufacturability. You can check against these rules using the design advice tool that we'll see later on. The rules themselves are created and adjusted in the document as and when needed. You can see on the right of the slide, we have a library with a list of rules, and in this design folder, there are no rules assigned. In the smaller insert picture, you will see under main body 1 that there is an entry called plastic rule. Polypropylene. This indicates that this component has the polypropylene rule assigned to it. These rules can be updated and assigned as and when needed during the design process. Moving on to the next slide, we'll be covering the presets. A preset gives you the ability to load a pre-configured set of values and options within the supported command. You can create multiple presets within a single command, and this allows you to quickly alternate between different design options. On the right hand side, we have a few examples of commands that can use presets. These are boss, snap-fit, and rest. Presets are available in various commands within the software. You would see the preset bar at the top of the dialog box when you are creating your feature. On this slide, we see that Fusion 360 default preset is assigned. But as mentioned, you can also adjust the values and save your own presets. The advantage of this is that you can create a feature, let's say a boss, on a component, and you can then save the configuration as a user preset. You could save multiple presets to easily switch between them and have the geometry update accordingly. This way, you can switch between multiple styles or types of bosses if geometry changes from one design to the next. With that, it leads us into our first demo. So here in our first demo, we will have a look and see if we have a plastic rule assigned to this component. So in the browser on the left hand side, we will see a plastic rule entry, and it shows us here that the plastic rule that is applied is ABS 1mm. If we want to see if there are any other rules available, we would go to the plastic tab. On the plastic tab, we can go to the setup and choose manage plastic rules. In the manage plastic rules dialog box, we will see two options as mentioned. In this design, I have two rules here, the active ABS 1mm as well as a nylon PA6 2.5mm. And then we have predefined library rules. So having a look at the two document rules, we will see that the ABS 1mm, as stated, has a thickness of 1mm, but we also have a thickness variation value of 0.2. Looking at nylon, we have a thickness of 2.5 with a thickness variation of 0.5 mm. So what this allows us to do is it would allow us to quite quickly and easily select a plastic rule to assign to the document. So we can right click here in the document, plastic rule, we can say assign a plastic rule, and we can go ahead and choose which rule we want to assign. So if I now change this to the nylon PA6 and hit OK, we will see that the design itself updates to show that change in the rule. So the thickness of the part has updated, and if the draft angle is different, we would see that the draft angle updates as well. So with these rules, it allows us to create different criteria for each rule. We can have a look at the draft angle, 2 degrees versus 3 degrees, and this allows us to quite easily change between those rules or those materials as and when needed with minimal input to the geometry to change the size. So let's have a look at how this geometry was created and how the rules play a role in the creation of this geometry. Let me actually assign the ABS back to this. And down here in the timeline, started off quite simply with a sketch and extrusion fillet. We have a draft angle here. If I go in and edit that draft angle, we will see that the angle for the draft is a parameter called dA. That dA parameter is the draft angle set in the rule. I'll hover over that, brings us up that tooltip which says value of 2 degrees, which was the angle for the draft angle for ABS. The same with the shell. We go into the shell feature, we will see that there is a inside thickness value of T, and that is 1mm. That was our ABS thickness. So by changing the rule, these features are parameter driven, those parameters being linked to the rules and updating those features as the rule changes. Now moving on from the plastic rules, let's have a look at the presets. As mentioned, there are certain commands that have presets. In this case, we are going to get a sneak preview at the boss command, but I'm going to go into that boss command because we have some presets, or this has the presets enabled. So here in the dialog box, if we look on the top right hand side, we will see the preset drop down. Currently it's set to the feature values. We have last used and Fusion 360 defaults, and at the bottom here I have created two predefined presets. So we've got M2 fine 3mm offset, which I think is the current setting. I'm just going to go ahead and switch off the section analysis. We can see what that boss looks like. And if I change that to the 4mm coarse with ribs, we will see that the boss diameter updates. We are now including a 4mm metric forming coarse screw, and there are ribs that are included as well. So quite quickly changing between these two presets updates the settings and the geometry and the options that are enabled within the dialog box. So I'm going to go ahead here, change that to M4 coarse, hit OK, and that will then update the model. So that demo showed the plastic rule and presets, but also gave us a quick preview of the boss feature, which happens to be the next command that we'll be looking at in the slideshow. And this forms part of the plastic design tools that the extension unlocks. So let's head back to the presentation and have a look at these. The plastic design tools can be found in the plastic tab and are plastic specific geometries that can be applied to your components. For example, here we see the boss command. We saw the boss command that can be used to add bosses within the design. The boss command allows you to pick center points that would be the center axis of the boss. It then generates the actual 3D geometry from the selected location, allowing you to create the geometry very quickly with minimal input. Once again, thinking about your designs or plastic rules and your presets that can be pre-configured. So the designer just needs to select the presets from the drop-down. You can generate that boss geometry quickly with it being preset and rule driven, but it is also customizable. Over and above this, you also have the ability to add fasteners. I'll be doing a demo where we can have a look at the boss feature dialog box, as what we see here is less than half of the information you are able to input. So that image on the right hand side there showing the compressed version of the dialog box. Along with the ability to quickly generate bosses within a design, you would also have the ability to quickly generate snap fits between components in a design. This can be done without having to manually draw out all of the sketches and extrusions to generate it. Once again, snap fit allows you to generate the geometry quickly, as it is also preset and rule driven, and of course it's customizable. You can change the type and orientation of the hook and loop that is used. You can see this in the dialog box at the top where we've got options with regards to the 3 different types. And we can also adjust the dimension for both sides of the connection as well. Moving on to geometric pattern command. This allows you to create more flexible patterns within Fusion 360. You are not stuck with using just a standard rectangular or circular pattern. The nice thing with this is that you don't have to have any geometry to start with. All you need to do is start the geometric pattern tool and pick a face. There are standard shapes that can be patterned on that face. If we have a look to the far right of the slide, we have 4 options where we see different geometric patterns using a sphere to cut out a dimple in those components. The bottom one is a cylinder, but we can choose those standard shapes to pattern across a selected surface. Not only this, but you can also customize the shape as seen on the side of the camera in the main image. That's the Autodesk logo that was created as a solid body in the part, which is then used as the source and patterned using this tool. You can use standard or custom shapes, but with this tool, you can also change the size and spread of the shape across the selected surface. Lastly, there's the distribution type. Hexagonal at the top right-hand image there, radial in the center of the 3, and lastly we have circular distribution. So the 3 patterns on the right-hand side represent the 3 different patterns. Just to note, the 4th one at the bottom is a hexagonal distribution, same as the top one. We're just distributing a different shape on a different surface. We'll now have a look at the rest command. This allows you to quickly create a flat area on the model with the use of a single sketch. The command then takes care of the rest, ensuring that the part thickness is adhered to. Once again, this can be preset and rule driven to help with design decisions, and all options are customizable to allow you to meet design requirements. We'll see in the demo as well that sketch is parallel to the plane that we want to create that flat rest, and so we can also adjust the shape of the rest from within the sketch. Lastly, before our demo, we'll look at the Design Advice tool. This tool would be used during and close to the end of the design process. It is used to check for manufacturability of the component. There are several factors that play a role in the successful molding of a plastic part, and Design Advice allows you to check for any issues relating to these factors. For example, a uniform thickness is desirable to prevent sink marks, and the Design Advice tool can check the part thickness and warn it if it is out of spec. We can see this in the top left image where it is shaded in blue, and the areas shown, and the green areas show the thickness change and highlight potential issues. Another thing to look for would be undercuts or overhangs. The bottom image shows an undercut where you may need to have a slide or an insert within the mold to help with the molding process. Then we'll look at the top right image where we have a draft analysis. Those faces that are highlighted in red do not meet the required draft angle set in the rule for the active plastic. In this case, they have a draft angle of 0. Lastly, the tool can analyze for knife edges. Now, we don't have any images of knife edges, but this would basically highlight any sharp edges that could potentially break off in the mold when the part is demolded. In the case of this part, they would potentially be at the top of the ribs if those ribs came to a sharp point. That would then be highlighted as a knife edge. So let's move back into Fusion and we will have a look at the camera as our start point. We're going to start off having a look at the bosses here. So in the timeline, I'm going to go all the way to the end of this timeline to find the boss feature. And in the timeline here, I'm going to highlight the boss feature, which is on the left hand side of the camera. So let's switch that over. And I'm going to go ahead and edit the boss feature. And as mentioned, or as we said earlier, this can be preset driven. But what we're going to have a look at here are the options with regards to the boss settings. Just a very quick look at what you have available to you. Now for the boss options, you will see that it has picked up the two sides of the camera, the left and the right hand side of the camera. And from those center points that were selected on the sketch, it is generating the boss geometry for both halves of this camera. So just to have a look at some of the options here, we have the visibility at the top where we're able to set our visibility settings for those components and the bosses themselves. We can also have a section analysis if we prefer to see the 3D model versus a cross section of the boss. Set offsets. If we go down for fasteners, if we want to include a fastener in this design, we can choose to create a component and we can select various options with regards to the fasteners. I won't go through all of these, there's going to be too many options to go through, but we can see we are able to select at least, the head size, the material, or sorry, the drive required for the fastener, the fastener dimensions. And once that is selected, you're able to then go down to the side 1 and side 2 settings. This is also broken up into your standard and advanced settings. So we'll see side 1 is showing us that it is the right-hand side, that is the part that it is connecting to, with a rule of polypropylene 3mm. And we'll see that we have a hole type specified and a step type. If we go into the advanced options, we will see all of the different dimensions that can be applied to this boss. So highly configurable. And we'll notice as well that these dimensions are all linked to, or mostly linked to, parameters. HD being head diameter for the hardware selected. We have thickness values as well within the options, and we will see the same for side 2. Now in this case, this left side, there's no plastic rule assigned to it, but we can still go to the advanced drop down and adjust values for the boss dimensions. If we wish to add any ribs to the bosses, we can go to the ribs tab, and on the ribs tab we can choose which side of the boss we'd like to add the ribs. Now if I go to side 1 here, which is the right hand side of the camera, and enable that, we will see the bosses are being created on the top side here that we can see. The ribs. Alternatively, we can create the ribs on the opposite side, side 2. And those ribs are then put in. And as with the boss itself, the ribs, you're able to adjust the geometry for the ribs within the dialog box. Once you have either created your preset or you have chosen your options, you can hit OK, and that would then generate that required geometry. Let that calculate out, generate the ribs. Once the ribs have been generated, we'll then have a quick look at the snap fit option. Okay, the ribs have been calculated. Let me go ahead and hide the right hand side, and we can see the boss with the ribs now included in the model. Now moving on to snap fit, we can see here that the center body has these two little snap hooks, so that the right hand side of the cover for the camera can be snap fit on. So here we'll have a look from the inside, the two components there meeting each other. If I switch off the central body visibility, we can see the other half of that snap fit. So we have that geometry on the two components. And switch off, so we just have the center. And what I'm going to do here is go down to the timeline and double click on snap fit to edit that snap fit. And much like the boss command, we get a preview of the geometry. In this case here, the rotation angle has set itself back to 0, so I'll change that to 90 degrees, and we'll see that the preview of those two snaps will adjust. And once again, at the top we have our drop down for our presets. In this case, I have not created any presets for the feature, but once all the options have been adjusted for this feature, we could click on the little plus on the right hand side to create that preset. I'm just going to call this my snap fit, and then hit the green check mark to accept that. And we now have my snap fit preset. Through here, you have a lot of the similar options to the boss command. We have visibility, so we can switch on visibility of the two different halves of the snap fit, either the hook or the actual loop itself, and the section analysis option as well. For the type of snap fit, because this is a parallel hook and groove that has been created already, I cannot edit or change this. So when you create your snap fit, make sure that you have the correct geometry selected, otherwise you would have to delete it and start again. But we have parallel hook and groove, perpendicular hook and groove, and then also a hook and loop option. Various selection modes, in this case we just use 2 sketch points, and we then have options to set rotation, dimensions, as well as right at the bottom we can go through for the hook side and the groove side and adjust the dimensions as required for both sides. For the demonstration purposes, I'm not going to go ahead and adjust any of those dimensions. I'm just going to go ahead here and cancel. It's just to give us a nice look at the snap fit. Now with regards to the geometric patterns, we will go to the right-hand side, and we need to switch on various components on the right-hand side. Here we can see the different geometric patterns within the design, and in the timeline we have the geometric pattern commands shown. So I'm going to go ahead and grab the central one here at the top middle, double click on that to edit it, and what we see here with this pattern is that we are using a predefined object type of cylinder, but we have sphere and box. There's also a custom option. So we see on the back of the camera a custom option was used, and I've switched that component off. So there, the Autodesk logo, the A, was the custom object used on that side. But once again, we've got the options to change the geometry as needed. We can set size limits for the object. So we can mold a small cylinder at maybe 0.5 or 0.3 is the smallest we can go, and the upper limit is maybe 1.5. And you will see that the geometry adjusts accordingly. 1.5 may be too big, we've got a little bit of a small, very thin surface there. We'll go down to 1, and your range will adjust. You can also change the spread. Do you want to tend more towards the small side or towards the larger side of that size limit that you set? The distribution type, we've got various options for distribution, so rectangular, triangular, hexagonal. I'll grab those, we'll see the pattern adjusts, and so you can quite quickly create nice tactile surfaces using these options. And for each of these we'll have different geometry settings for alignment and position and dimensioning according to that. So that's a quick look there at the geometric patterns. And for the rest, I am going to go back to the original rib box here. And the rest command essentially requires just a sketch at the position of the flat rest that you want to create, and also parallel to that plane. So in this case, I've created just a simple rectangular box. And the rest command allows you to select that profile and then adjust either the presets. You can predefine a preset, and you can also then adjust your values. You'll see that it pulls values from the rules with the thickness, the T and DA for draft angle, and you'll be able to adjust your values as needed for this. Now, the interesting thing about the rest command is if I step the tree back, you will see that this part had a straight wall, and if we move that timeline forwards, when the rest is created, because it overhangs that wall, it automatically steps out the geometry to create that complete rest. But turn this to the inside, we'll also see that the wall thickness is maintained according to the wall thickness of the rule, at ABS 1 millimeter in this case. So that rest is able to adjust the geometry as required, rather than just adding extra material on. And then lastly, while we are in this tool, we'll have a look at the design advice. That would be on the plastic tab. We go to inspect and we see the design advice option there. Select the solid body and your pull direction and select analyze, and it will then analyze for the selected options. So we have thickness, undercut, draft, and knife edge, those 4 options. So going across the tabs, we can check for thickness, And in thickness here, I'm going to go full range, and we can then see the full range of warnings on the thickness. So we can see the areas that are shown in blues, the teals and oranges and reds are warning areas on the model. So we have some issues here where the thickness around the boss is quite thick. It's a lot of material. Also the block on the side of the part there as well. Undercuts, this will show us where we have undercuts in the model. So we can see here definitely where this block overhangs. We've got an undercut underneath that block. Draft angle, you can see these are vertical walls that do not meet requirements, and here we can actually go and choose an alert and it will highlight in the model. And that's true for all of these. Knife edges, you can see we have a couple of knife edges that are showing here potential issues that we can look at and potentially change geometry to save once you change that. So we've got those various alerts. You can go through and view them and make changes as required. Run that analysis again. So it'll bring us to the end of this demo. We'll move on to the volumetric lattices. We'll move on to organic mesh conversion. So here by default, the convert mesh tool allows you to create either a faceted or a prismatic result. Prismatic would try and fit primitive shapes to the mesh as best it can. So if you have a mesh that is in the shape of a cube, it would convert that mesh into a cube that has its 6 flat faces. In the case of the Einstein scan here, it's a bit touch and go whether or not that prismatic would work. Depending on the scan surface itself, your results may vary. The convert option also allows you to create a faceted surface. And converting to this faceted surface is also not always the most ideal solution, as it leaves a rough surface. We can see on the left hand side the mesh. The model that I've got in Fusion will actually see the 3 different options next to each other, but faceted leaves that rough surface. With the product design extension, organic mesh is added to the dialog box. Organic mesh conversion is a great tool for users who are wanting to reverse engineer scan or mesh data back into solid geometry. Using organic mesh conversion, the mesh can be converted into a T-spline surface. We can see that in the slide on the right. And this surface can be edited using Fusion's form editing tools. If the T-spline is closed and watertight, it can be then converted into a solid body. And moving from mesh to the volumetric lattice tool, I think the easiest way to explain this lattice tool is, and what it does, is to draw comparisons with what is called infill in 3D printing. I know at least Cura calls it infill, where the material is removed from the inside volume of your part. Now, this not only reduces the amount of material required to print, but also reduces the weight of the part. Using the volumetric lattice tool allows for designers to include this internal structure at the design phase, whether it is for function or aesthetics. In the image here, we see the handle of the camera has had material removed to create this open cell webbing or foam-like structure. This may help for comfort when using the camera, or just be there as a cool factor and setting point. When creating the lattice, you have a set of cell shapes to choose from, essentially the shape of the infill. This can then be scaled as required. Solidity is an option that essentially equates to the density of the lattice being created. A lower value will result in more open lattice, and a higher value will create a more closed lattice, or a higher density. Offset values. Offset allows you to select faces and edges where you want the geometry to stay solid. These are areas where the lattice will not be generated. We can see this on the curve of the handle. The lattice itself is created as an object in the model browser rather than a feature in the timeline. So let's have a look at the demo for those two quickly. We'll go have a look at Einstein here. This is a mesh I downloaded offline, and on the left hand side we have the mesh body itself. If we go into the mesh tab, under modify we have the convert mesh option. Now the second and third objects we have here, those mesh bodies are the results of the standard convert mesh methods of faceted and prismatic. We can see the faceted, if we turn off the edges, we'll just set to shaded, results in this triangulated or faceted solid where we have lots of triangles creating that overall shape. The prismatic surprisingly worked very well on this one. We get one solid with a continuously smooth surface throughout that component. And then the third option is what is unlocked in the extension, and that is the organic. Now, before I go into the organic, just a couple of things to look at here is to consider your editing, if you need to edit the components further down the line. If we look at the standard mesh itself, we are limited to our mesh tools within the modify or create sections in the mesh panel. If we look at the faceted and the prismatic, that would be pretty difficult to edit because we would have to be using things like direct edit or our standard solid modeling techniques to make any changes to this. And it's a very organic shape. It's a person. So using the standard modeling techniques may be very difficult on these surfaces or on these solids. These are solid bodies as well. The third one, using the organic mesh conversion, I'll go down here, convert mesh. I'm going to grab this first one and then go to the organic mesh. That converts into a T-spline. And so if we change the edges to highlight, we can see that this is a T-spline surface. We can also see with the icon that is T-spline. So the method for organic allows you to choose your resolution. So you can go by accuracy or the T-spline to accurately represent the mesh, and you can set your accuracy level low up to precise. Or you can choose by face number. You can say, I want my T-spline to be a 500 face T-spline, and we end up with 500 faces on the T-spline itself, front and back on this mesh. We also have a process holes option. So if there are holes in the mesh, they will be patched and the T-spline surface will be created as a watertight surface. I'm not going to click OK here, but because that's going to take some time to calculate out. We are getting a warning that this mesh has more than 10,000 triangles, so calculation will be a long time. It takes a couple of minutes for that to happen. I'm going to hit cancel, and I'm going to hide the other three just to show you with this scan or with this resulting T-spline surface what we can do. Just a very quick one here. I'm going to go to the form tool. Going to edit the form, grab a few points there. Let's say move that out, maybe scale it a little bit. Very quickly and easily change that geometry. Whether you're making a mask or something that requires you to adjust the geometry, you can see that we can grab all of that and we can make those changes as in how they are needed. And so here we've got Einstein with a much bigger nose on his face. And so you can make the changes you need to that organic mesh and have that converted into a solid which you can then work with in your designs. Moving on to the last demo item, we'll look at the the volumetric lattice. Here I already have the lattice applied to a cylinder. We can see the lattice is shown in the browser as a volumetric lattice. If you want to edit that lattice, you would go and double click on that lattice in the browser, I'll right-click edit volumetric lattice, working a little bit better for me. And in here you have the options as mentioned in the presentation. Now what I'm going to do here is rather delete this lattice and go ahead here on the plastic tab, go to modify volumetric lattice, and we'll select the solid to apply the lattice to the solid. And I'm going to make a few changes. The cell shape from gyroid, I'm going to go to X cell, and you can see that that changes the shape of that infill. We can adjust proportions. I'm going to uniformly scale this so that the cells are a size of, let's say, 25 millimeters to make it a lot bigger. And we can also adjust and move the position of this lattice. So we can rotate that lattice around, so rotate it 90 degrees or 45 degrees. You can make those changes as needed. The solidity or the density of the lattice can be adjusted. We've got a slider here to adjust it uniformly, or you can adjust a gradient along a specific path. Now I don't have that anything set up for that. I'll go back to uniform and make quite an open cell option here. I'll go down, and then lastly offset. You can choose to add a surface or an edge, and that would then allow you to create a thickness offset from that surface. So maybe the bottom 10 millimeters of the cylinder, I want that to be solid, and you will see that it adjusts for that. Now we have thickness, we have a blend distance, so I'd say a blend across 5 millimeters with the solidity that offset. Maybe we want to change the solidity to 0.8. And you can see that it creates a different cell structure to the rest. I'm going to keep that at 1, so it's a solid base on the bottom. And that there allows you to create those sort of cellular structures, that volumetric lattice structure within a component. Save weight, give you an idea of what it would look like when it 3D prints. It could even be functional, it could be a filter of some sort. And so that there brings us to the end of the demo. We are nearing the end of the hour, so we'll go through the summary and we'll close off the video. So in closing with the summary, I'd like to highlight a few of the main points covered in this presentation. Companies and designers are always looking for ways to improve their productivity. Beating your competitor to the market is important. This means that the design process needs to be streamlined to speed up the design and changes. The product design extension gives users the tools to automate designs using rules and presets, removing the chance of the users second-guessing themselves. The use of these tools can instill confidence in the user and the design as consistency is enforced. This consistency can be carried forward into plastic part design with more complex geometry. The inclusion of geometry-specific tools such as Boss and SnapFit allow for quicker creation of complex parts. Once again, with the assistance of plastic rules and presets. Towards the end of the design cycle, the user can access the design advice command to verify the part's manufacturability and check for thickness variation, overhangs and knife edges. If plastic part design is not what you do, you may still be interested in the benefits of other tools available. We looked at the mesh to T-spline workflows for reverse engineering, as well as volumetric lattice for more advanced part design. Not to forget that presets can be used even if your part is not going to be molded from plastic. So to end off the presentation, I'd like to thank you for watching. And if you are a Fusion 360 user, I'd like to ask you to view the extensions within Fusion 360 by clicking the little extension icon on the top right hand side of your Fusion. Have a look what is available, and you might be surprised at what you find to help you with your day-to-day work in Fusion 360. Thank you once again for watching this recording. This has been a Micrographics and Autodesk webinar covering Fusion 360. If you'd like to contact us, we have our webpage, mgfx.co.za. You can also contact us at info@mgfx.co.za. And thank you for watching this video. If you enjoyed the video, please like the video and also subscribe to our channel for more videos that will be coming out, and also for our videos that we have already placed up. Thank you so much and have a good day.